All right, and so for section 7.4, let's talk about arc length. This is to me, is one of the more fascinating applications of calculus. So something that you have learned in a previous algebra class, or some kind of, or maybe even pre-calc or calc 1, is the distance formula. And so the distance formula is the difference between our x values, so x2 minus x1 squared, plus the difference in our y values squared, and we take the square root of that entire quantity. Okay, the distance formula has its benefits and its uses. The problem with the distance formula is it only tells you the straight line distance. What we want to know is whatever arc that we have between those 2 points, the length of that arc. Okay, and the textbook represents it with S. That's a commonly accepted way to represent arc length, is just use S for whatever reason. But it's the integral of the square root of 1 plus the derivative of the function squared, and that integral is taken with respect to dx. All right. So let's look at an arc length, or excuse me, let's look at a distance between 2 points. Between, let's go with the points 3, 3, and 6, 5. So 3, 3, and 6, 5. So the distance is the square root of 6 minus 3 squared plus 5 minus 3 squared, which is 3 squared, 9, plus 2 squared, 4. So the distance between those 2 points is 13. All right. So the distance between the 2 points, all it gives us is, again, if it is a straight line value. All right. However, in something to compare here, let's assume that we do have a line. The arc length will still tell us the distance, but we have to generate that line function. So I have to figure out my slope, which is 5 minus 3 over 6 minus 3, which is 2/3. Then I use my y minus y1, x minus 3, x1. And I figure out that my y is equal to 2/3 x plus 1. Okay, so the line that connects those 2 points is 2/3 x plus 1. All right. Now to find my distance formula, or to find my arc length, I need to know the derivative. Well, the derivative of 2/3 x plus 1 is just 2/3. And so what I am going to say is that my arc length is the integral from 3 to 6, because that's my x values, of the square root of 1 plus 2 over 3 squared dx. Okay. And I'm going to go ahead and flip to the next page here. So I have the integral from 3 to 6 of, really what I have is 1 plus 4 ninths. Which is the integral of 13 over 9, which is the integral of the square root of 13 over 3. Okay, and this is all with respect to x. So the integral of that is the square root of 13 over 3 x from 6 to 3. Okay, so then I just do my upper limit of 13 over 3 times 6 minus my lower limit of the square root of 13 over 3 times 3, which is 2 times the square root of 13 minus the square root of 13, which equals the square root of 13. All right, so that confirmed that on a straight line, my distance formula is, since I am talking about a straight line, that I have confirmed that with the arc length. Okay. Let's say that I am given, let's look at another example here. Let's say that f of x is 3x squared plus 4. And I'm going to look from x equals 0 and x equals 4. Okay. Then my derivative is f prime of x is 6x. All right. So my arc length, because the distance formula doesn't do me any good here because I'm on a curve, so my arc length is from 0 to 4, the integral from 0 to 4 of 1 plus 6x quantity squared dx. Which is 36x squared dx. Okay. And then you would just do the integration here using UDU substitution to integrate this, okay? But what we'll find is the problems that I've selected here are very straightforward and simple, so you won't get any like crazy type derivatives to plug in, all right? But it's just another example of how Calculus 2 is used when measuring or an application of integration. All right. So with that being said, if you do have any questions, please feel free to email me. And as always, have a great rest of your day.